video is about graphing simple rational functions. Let's start by defining what a rational function is. The general form for a rational function is going to be f of x equals p of x over q of x. So we know rational means fraction, right? The first 5 letters are ratio, which means fraction. And in a rational function, we're going to have some expression on the top involving x, and we call that one p of x, and then some expression on the bottom involving x, and we call that q of x. So you might have x on top and bottom here. In some cases, we'll have it only on the bottom. So an example of one of these functions might be something like a whole trinomial on top, maybe x squared minus 2x minus 12. And on bottom, maybe x squared minus 4. This is a good example of a kind of complicated rational function, which we will learn how to graph. We're not going to start with those, though. We're going to start with the most basic rational function there is, which is f of x equals 1 over x. This is the parent function for all the other rational functions. The numerator is a very simple polynomial. It's the number 1. It's a constant, so the degree would be 0. And the denominator is just x, which is a linear expression. The degree would be 1. It's the most simple rational function that we can get. So we're going to start by learning how to graph these. On the next slide, we're going to see a picture of what this graph looks like. Okay. To graph a rational function, any rational function, you want to start by drawing your asymptotes. And on this graph, they don't show them, so I'm going to fill them in as red dotted lines. We have a vertical asymptote at x equals 0, which is located here up and down the axis. That asymptote exists because x can't equal 0 when it's on the bottom of a fraction like that, when it is the bottom of the fraction. So the graph is going to approach that, but it's never going to cross it because x can't be 0. And there's also a horizontal asymptote on this rational graph, and that's located here along the x-axis. So we have these two asymptotes creating this cross shape, and then the actual function itself appears down here in the bottom left corner. This is one branch of it, this blue curve, and it appears also up here in the upper right corner. It's the other branch of the curve. So this is what the parent function looks like. Most of our graphs are going to look something like this. Sometimes the function will appear in the upper left-hand corner and the bottom right-hand corner. And the only way we're going to be able to figure out where the branches show up is by making a table. So let's try one. Like I said, the first thing we want to do to graph this function, it's y equals 6 over x, is to draw our asymptotes first. Now there's no h or k in this problem, so the asymptotes haven't moved. They are still located at 0 on the x-axis, 0 on the y, and then some vertical and our horizontal asymptotes. Now to figure out where the branches are going to show up, we're going to make a table, an xy table, using 4 points. I want you to pick 2 points on the left of the asymptote, the vertical one, and 2 points on the right of it. So I want 2 points over here and 2 points over here, so we can figure out where the curves are going to show up. So to the left of 0, we have -1 and -2. And to the right of 0, I'll use 1 and 2. I just like those numbers. They're small and simple. Now, because we're dealing with fractions, we may end up with some ugly numbers on our table. If you want to use decimals, that's fine. Lucky here we have all whole numbers, so we won't have to worry about it just yet. 6 divided by -1 is -6. 6 over -2 is -3. 6 over 1 and 6 over 2. All right, so we have whole numbers. Let's graph these. -1, -6 is located down here. -2, -3 is located down here. And then we have +1, +6, and we have 2, 3. I'm just being kind of approximate here. You don't have to be perfect. All I really want to know is which corners are these two curves going to show up in, and then do the best you can to connect the dots and get close to your asymptotes. You know that this graph is going to be approaching the asymptotes without ever actually crossing it. See, I missed that point there, but I'm not going to go back and fix it. It's close enough. And I want you to state the domain and range, which for all of these is very similar. The domain is going to be all real numbers except for the place where x has an asymptote, which is at 0. And then the range is also going to be all real numbers, except for the place where y has an asymptote, which here is also 0. Okay? This is a lot of words. It's just guidelines for how you should graph something that has an h and a k. Now, since we've done this so much, I don't need to read through all of this. But I do want to highlight this important thing right here. This is the formula, and it shows you that h is with x in the denominator of the fraction, And k is the number that comes after the fraction, just kind of being added or subtracted at the end. So if you're trying to figure out which one's h and which one's k, remember that h is the one that's with x, always. Okay? So h and k are going to move the asymptotes around. As you can see on the little picture over here on the right, the k determines where your horizontal asymptote moves, and the h determines where your vertical asymptote moves. So let's try one so you can see how this is going to work. Okay. Like I said earlier, first thing you want to do is get your asymptotes on the picture. So the asymptote that would have been vertical at 0, right, it would have been here, is going to be moved with h. Now h is a +2, see that there? Which means it's going to shift 2 units to the left, because h is the opposite. So my vertical asymptote is actually going to be at -2. All right, and then the horizontal asymptote that would have been at 0 is going to shift with k. So k, as you can see here, is -1. We don't do the opposite of that. We do exactly what it says. So our horizontal asymptote is going to be at -1. And now we're ready to make our table to figure out which corners will our branches show up in. Okay, so x and y. Now we're not always going to be able to use -1 and -2 and 1 and 2 because our asymptote has moved. The asymptote is now at -2, the vertical one, and that's the one that matters for picking our numbers here. So if we're picking -2 as our middle, we want two things on the left of that, like -3 and -4. And we want the next two things on the right of that, which are -1 and 0. Right? I use whole numbers, it's simple. And then this time, when you plug these in, I actually do want you to put h and k into the table. I want you to figure out exactly where the point is going to be. So you don't have to do any shifting once you fill in your table. For these functions, it just gets a little too complicated. So we actually want to plug in -3 to the function where x is. And I want you to do the +2, and I want you to do the -1. Okay, now the numbers are usually going to be pretty small, like you can do them in your head. If you need to use a calculator, just be careful with the fraction, right? Make sure you're using parentheses. All right, so I'm going to do this in my head. We have -4 over -1, which is 4. 4 minus 1 is 3. Then we're going to plug in -4 for x. Now we have -4 over -2, which is 2, and 2 minus 1 is 1. Then I'm going to plug in -1. Now we have -4 over 1, which is -4, minus 1 is -5. And then I'm going to plug in 0, and now we have -2 minus 1, which is -3. All right, I have my points ready to be graphed. I'll be as precise as I can be. -3, 3 is going to be in this corner, -4, 1, and -1, -5, and then 0, -3. Okay, now we have our branches showing up in the upper left corner and the bottom right corner. Do the best you can to connect the dots and get close to your asymptotes. It's okay to cross the axis. You just got to be careful that you don't cross your asymptotes. And there's our rational function. The domain is going to be all real numbers except for the thing that x can't be, which is -2. The range is going to be all real numbers except for the thing that y can't be, which is -1. Okay. Then, on the back of your homework, there's 3 different types. Now these functions, as you'll notice the formula on this slide, have x on the top and the bottom. We haven't done one like that yet. And there's some different rules that you have to follow because you can't really see h and k when you've got x on top and bottom. Okay, so we're not going to be able to use our h and k anymore to get the asymptotes. So what you're going to need to get the vertical asymptote, I'm going to abbreviate that to VA from now until the rest of the end of the chapter. Okay, to get the vertical asymptote, you want to take your denominator, which is in this formula is cx plus d, and you want to set it equal to 0. And then solve for x to figure out what is the one thing that x can't be. We've done this before. This is nothing new. I don't know why they're giving us letters instead of numbers, so we'll deal with these letters here. Subtract d, cx equals -d, x equals -d over c. And that's where our vertical asymptote will be. The one place that x cannot equal is where the asymptote is going to be. For the horizontal asymptote, in an equation, a function that has x on top and x on bottom, no exponents yet, just plain old x, the horizontal asymptote is going to be located at y equals a over C. And you can look at where the way the formula is written. A and C are just the leading coefficients. So our asymptote, our horizontal asymptote, is going to be located at y equals the leading coefficient at the top divided by the leading coefficient at the bottom. This will make a lot more sense with numbers, so let's try one. So I notice I have x on top and bottom, which means I can't use h and k, but I still need to get my asymptotes on there first. So my vertical asymptote is going to be located at, I need to set the denominator of the fraction equal to 0 and solve it. So x equals 3 is where my vertical asymptote is going to be. I'm going to put it right on the graph now that I know where it is. My horizontal asymptote, because I have x on top and bottom, no exponents yet, the horizontal asymptote will be located at y equals the top coefficient, which is 2, divided by the bottom coefficient, which is just a 1. There's a 1 in front of this x. So y equals 2, positive 2, is going to be my horizontal asymptote. Now I've got my cross drawn. I got to figure out which corners my branches are going to show up in. So I make my xy table. 2 points on the left of 3, how about 2 and 1? And 2 points on the right, like 4 and 5. Plug those in. You can either use your calculator or your brain. And these might give us fractions. You can either use fractions or decimals on your table. It's up to you. All right, 2 times 2 plus 1 is 5. Over negative 1 is negative 5. 2 times 1 is 2 plus 1 is 3. Over negative 2. Which doesn't simplify nicely, so there we have it. 2 times 4 is 8, plus 1 is 9, over 1, all right? And 2 times 5 is 10, plus 1 is 11, 11 over 2. That doesn't simplify either, so we'll leave it like that. It's about 6. This is about 6.5, no, 5.5. And this one's about negative 1.5, right? If you're using decimals, that's what you'll have on your table. Let's graph these points. 2, negative 5. Down here, and 1, negative 1.5. And then we have 4, 9. It's a little bit off the graph, but that's okay. And then we have 5, 5.5. Like I said, it doesn't have to be perfect. I see which corners they're in. Make sure your curves get close to the asymptote. Close to the asymptote. Try to go through your points. I missed that point a little. And then our domain. And is all real numbers except for the thing x can't equal, which is 3. And the range will be all real numbers except for the thing that y can't equal, which here is 2. Okay? Good luck.